morning. We're here together to figure out how to do a bit more of the predictive analytics. But mainly we're looking at one more prediction model. In this case, we want to look at a prediction model where we want to say to what extent can we explain how much a movie grosses. So we've got all these different things. Say how much the movie grosses would therefore be your y variable. You want to explain what are the things that lead to it. And all of these things out here, things like the duration of the film, the number of likes for on Facebook for the director, the number of votes casted for the movie, the number of total Facebook likes for the entire cast, the budget of the movie, the score of the movie, the number of Facebook likes for the movie itself, and whether it's in color or black and white. Well, we are hoping that would explain how much a movie grosses. The question is, how much does it gross, and how would we start prioritizing where to focus? There's a social media data, so the question comes at, all right, where should we spend more money? Should we spend more money on social media? Should we put all these advertisements into Facebook and this and that and all that stuff to ramp up interest and excitement about the movie? Because if it doesn't end up working, it's going to be sunk cost. So it gives you a sense of not only the magnitude, but also what you should prioritize. Now, of course, one quick thing to do, which is a good bit to do, is once you go there, once you start doing a basic filter first. When you do a basic filter, what it gives you a quick snapshot. For example, if we wanted to look at duration. So all I did was click on filter. So if I toggled it, if I click on filter again, it filters it. You can see that small drop down marker out there. And now it says that, all right, the duration seems to be the movie with the shortest duration seems to be about 34, and the longest duration seems to be at 330 minutes. So it gives you a quick sense of what it is. So if you wanted to filter forward, so for example, in this case, suppose you're looking at the number of the movies we have in color. You see you've got 0, 1, which would be color versus black and white. And if you just wanted to see the movies that are in black and white, in color, then all you do is there, and you only have the films that are in color itself. And on the other hand, if you were to look at the movies that are only in black and white, you immediately look at that and tells you 133 of the 3878 records are actually in black and white. So let's go back and make sure we select it all. And after that, what we're going to do is let's try and make a quick run. Now this is a slightly different database, so don't worry too much about getting exactly the same numbers everywhere. So what we'll do is we'll start by doing a quick correlation. So we go to data analysis because we want to see how they match up with each other before we start understanding causality, what causes the other. So go to correlation. Okay. And now they're saying, where do you want to see the correlation? And we'll say that, all right, we want to look at the correlation between everything from duration to the gross of the movie. And instead of going all the way down, on a Mac, I'm going to go Command Shift and down arrow, and it captures 3,879 rows. Now, the number of rows you might have might be slightly different because it might be a slightly different data set, but let's work on this. And we'll say that we'll put that in a new worksheet ply, and we'll call it correlation. And then click on OK. And now we have a correlation worksheet ply that gives you an interesting, quick look into how things actually tend to impact. Now, because that's our y and these are all our x's, just by looking at it, you see that, all right, there's some correlation. There's every time between duration and gross, there's a slight positive correlation, positive but lower correlation between, let's make sure we can read it properly. Facebook likes for the direct term, a stronger correlation between voted users and the gross. The number of likes for the cost, somewhat of a half-decent correlation. Budget, some low but a positive correlation between all of them. Now then comes this whole idea of, all right, let's look at how there is between Facebook likes and duration, there's a slight positive correlation. Let's look at some of these negative correlations. See, between color and black and white, so all it says is it's a negative, but a very, very, very low negative. So as you're saying that if black and white is 0 and color is 1 and duration, there's a negative effect between these two. All it means is that with whether you have a black and white movie to a color movie, color film typically will have a slightly lower duration. You'll see that same thing out here too. Important thing out here is to get a sense of if there are some very high correlations between the variables that you think that are the X variables. Because if there's a very high correlation between two things that you're trying to use to explain the gross, you might say that, hey, they're basically redundant. Think of it. If two of them are just about the same, they'll have a very, very high correlation. And then the question comes, why do we actually need both of them then? Why can't we simply have one of them? So in this case, the ones that have somewhat of a higher correlation between themselves is between IMDb scores and number of voted users. And that makes sense because this is an IMDb database. There's a likelihood that the higher the number of users, the higher the IMDb score. But somewhat there's a 0.47 or a 47% correlation between them. Now that really doesn't mean much, except for the fact that you might be able to come up with some degree of inference that when people get excited, positively excited about a movie, they tend to post a review more than when they're negatively dampened by a movie. So that's why you might find this slight bit, but we really don't know. That's just a basic conjecture. And you'll also see that number of voted users and durations, there's a slightly high positive correlation, but that again shouldn't be terribly much of a bother. IMDb score, so duration and voted users. So people tend to again get interested in movies that are longer because it might have a longer plot line, more complicated plots, more interesting plots, because of which more people want to go and watch the movie. Going back, so we've found a basic idea of correlation, and then from there we're going to look at how do we start predicting. Now, in order to do that, we'll do a basic regression model as a prediction model. Click on yes, and then in the y range, as we've marked out here, this is y. So what we'll do is again Command Shift down K, so that we've captured all of them, and for the x's would be the rest of the set right out there, which is going to be everything from duration right up to whether the movie's made in color or not. And again, Command Shift and down K. Make sure that the first row, if you have labels, has labels, marks. And let's create a new worksheet ply. Call it prediction model. And let's click on OK. And there you find the prediction model or the general regression model that tells you how are these things related and how well do each of these things explain the the amount of money the movie grosses. So in this case, what we look at is there's something called the intercept. The intercept basically means that if you didn't consider any of these variables, how much is the movie likely to gross? So even if you didn't consider the duration of the movie or the Facebook likes, because there are so many other variables that could impact how much a movie grosses. So that's the intercept. And then these are all our x's, and we'll get to it in a tiny second. But first, let's start with first things first. So let's start marking them. This is an important number, which is adjusted R-square. So the adjusted R-square basically tells you that things such as duration, number of likes for the director, number of voted users, the likes for the total cost, the budget, IMDb score, the likes for the movie, and whether it's in color or black and white, explains about 42.66, about 43% of the variance in how many dollars the movie grosses. So this simply means that things such as duration right up to color or / black and white explains nearly 43%, that's 42.66, we're just rounding it up, of the variance of the dollars crossed by the movie. That's what it means, right? So you're trying to see how well can you explain, which is not terribly bad. So you're saying that, all right, let's look at social media plus general features of the movie, and let's see if they actually try and explain what we want to get at, which is how much the movie grosses. So that's the first piece, which is very, very important. Next piece we move on to is something called the p-value. So let me mark that first, and especially this section. Don't worry too much about the intercept right now. We'll talk about those things later. So we'll mark that out here. So that's the p-value. Let me mark that too. And what exactly does the p-value mean? So let me see if I can mark these in a proper way so that you know which one to correspond. In this case, the p-value basically tells you whether there is a significance or not, which means, does it actually matter? Was that just a random, by chance impact, or is there really a statistical grounding? Now, because we chose 95% confidence, our level of significance is nothing but 1 minus 95, which is going to be 5%, right? So we want to basically see if each of these values fall under 5%. In that case, we can say that, well, it's not just random happenstance. There seems to be a proper significance. This seems to be a systematic mechanism or a systematic assessment of whether each of these x's make sense in explaining the y. So what we'll do is we'll again say, actually we'll just write a quick function, which is if this value is less than 0.05, which is 5%, right? Then yes, or then within inverted commas, yes, else say no. So all we're saying is, if this value, if it is truly statistically significant, then we'll say it has to be less than 5%, which is 1 minus 95%, and then say yes or else say no. So we click yes. Now let's run that bit right up to here, and you see all of them are yes. Now, in case you're wondering, what does that E minus 0.6 mean? All it basically means is prior to that the decimal point, because it's such a long number in the negative, it couldn't fit it in. So it basically says it would be 5 zeros before the 1, That's how low it is. So it would otherwise actually, the actual number would have been 0.00000161, but it couldn't fit it. So if we ever wanted to really look at the number, all you do is go into format cells, go into number, instead of 2 decimal spaces, let's say we create that, and now you see the number change immediately. You've got 1, 2, 3, 4, 5 zeros, right? And 1, that makes it 6, and right after the 1, so we could just say okay, and now you suddenly see that that's actually the full number, which is nothing but, if this is the same bit as this, because all this means is E-6 just moves the zeros by 6 sets, so that it actually looks like it's somewhat structured rather than unstructured. So once again, so we're looking at whether it's significant question mark, and this is where we find that bit. So we see that all of them are significant. Now comes this whole idea of, all right, how do we actually explain what these mean, which takes us into something called the coefficients. So these coefficients are important things, and let's first create a marking for it. Let's not terribly excited about that color, but we'll make do with what we have. And these coefficients basically means how much do they impact. Now do realize your y is, so in this case, y is the gross for a movie in dollars. So everything has to be explained in dollars. And the best way to explain it is always, so first we talked about the intercept already, which means that assume none of the things we tried to, or we used, were taken into effect, because there are so many other things that explain why a movie grosses. The movie is likely to make 288,390, how much is it? Let's say $28,839,063, right? But right now it really doesn't mean much other than it's a good set just for a prediction model. So don't worry too much about it. That means that that's where it starts. So if you ever were to look at any modeling, let me see if I can find a way to quickly draw a line. So if I were to draw a line, like a regression line, and then another one here, let's say, so suppose that's X and Y, you're trying to explain profit, or sorry, the gross, based on each of these variables, you're going to find some kind of a slope, right? So you're going to find some kind of a slope, and this slope is likely to be either here, and that would basically mean, if it went like that, it would basically mean everything explains why a movie grosses, which basically means if you didn't consider all the x's, your y would be 0. Now in our case, it says that no, there are other things that explain it. That's why your y is not 0, but 28,839,063. So it's somewhere out here, right? So we haven't been able to explain this part. So that's important for you to know. So this is known as the slope. And this part, this missing part out here, is called the difference between this and this section is called the intercept. So that's all it shows you, that's the coefficient for the intercept. Now, let's go through each of them. Duration of a movie. So all they're basically saying is that every time you do an x to y modeling, you're trying to figure out how much does this is called marginal shifts. So how much does a marginal change, or a change in 1 minute of movie making, impact the gross that the movie makes. So in this case, how much is it? It's $198,227.66. So you should be saying that, all right, if this were to be the case, I would say that so let's rewrite these, and then I won't explain all of them, or I'll explain all of them, I won't rewrite all of them. So in this case, you'll say that because it's marginal, you're looking at change in one single unit. For duration, what's the unit? A minute, right? So for every extra minute movie runs, it makes, or it grosses, let's just use the proper term for it, it grosses $198,227.66, right? So that's all it means, that if you were to add a minute to a movie, it's likely to increase your gross. Now, you might say, well, why not just keep on adding more minutes? The question is slightly trickier, or the response in this choice, this decision is slightly trickier than what appears to be obvious, which is that, wait, but to add one more minute doesn't automatically mean that the other extra minute is free. Every minute might be a result of 30 more minutes of an hour extra of filming. So for every 60 minutes, you end up choosing 1 minute on the editing platform, which means that, all right, to shoot another 60 minutes from which you're likely to get 1 more minute, will it cost you? Think of it. Will it cost you less than, equal to, or more than $198,227.66? If the answer is, well, it's going to cost us less, the response should be, sure, keep adding more minutes. But if you realize it's going to cost you more, not only will it cost you more, but there's also some uncertainty related to it, then you would say that, all right, so we might not want to go ahead with it. So you have to understand an extra minute of movie addition doesn't automatically mean one just extra minute of shooting. It might mean 1 more hour of shooting or 2 more hours of shooting based on how your editing room works. Same thing with director Facebook likes. It basically says that for every additional, let's say additional Facebook like for a director, the movie gross, this is interesting though, falls by how much is it? 12 to $1,255.98, which is very interesting. So all it's saying is, if you have more likes for the director, the movie gross falls by $1,255.98, which could very well mean that a lot of likes are for directors that work in independent movies, or directors for shorts and directors for more art house movies, which may not be making a lot, which may not be grossing a lot. But the directors, they love all these very technical camera angles and acting directions and all that stuff by the director, which does not always equate to more popular movie. So all it's saying is that the popularity of a director does not automatically spell the popularity of a movie. Interesting thing to think about. Then similarly, if we are to look at the number of voted users, every time you add 1 more voted user, you seem to be increasing the movie gross by $293.02. which is this one, and then similarly, uh, likes for the Facebook cast. Every time Facebook likes go up by one for the entire cast, you seem to be making $284 extra in gross. IMDb score is actually interesting, which sort of works in line with what we talked about the director. So what does the IMDb score mean? So we'll write that bit out, which basically means that every time the IMDb score, so every time the IMDb score, rather than every time, I say each time, IMDb score goes up, score for a movie goes up by 1 point, the movie grosses less and falls by dollar. How much is it? Good heavens, 79 million. No, $7,900,205 falls by $7,900,205.63. So think of it. Every time the IMDb score for the movie goes up by one, the movie gross falls. Again, it might actually hint at the fact that higher scoring movies are not always the most popular movies, just like better rated directors may not always be the directors for the most popular movies, and there seems to be a negative relationship between them. And I'll do one more, which is same thing. All right, quickly. Every time budget goes up for a movie goes up by $1, the gross actually doesn't always relate to it. The gross goes up by what? 0.0165. So about 1.65 cents. So every dollar extra you spend on the budget, your gross only goes up by what's that? 1.65 cents, which is worrisome, but it also then sends a signal to you that, wait, even the duration seems to make more money for us. Increasing the duration is going to cost us, is going to increase our budget. Yet every time we increase the budget, the gross falls. So you have to come up with an optimal choice. So you just can't keep increasing the length of a movie, because even though the length of the movie works, the budget, which is also related to the length, does not always work very well. So that creates a bit of a sticky situation. Again, every time the Facebook like for a movie goes up by one, the gross for a movie seems to increase by about $171.27, or you could say just round it up to $171.30. And again, black and white is 0, color is 1. Every time, if a movie is shot in color versus in black and white, you could say that the gross for the movie is likely to go up by $17,545,329.82 versus a color movie, versus a black and white movie, which is going to likely to reduce it by 17,545,329.82. So that's what it means. Now, given the fact that these are all significant, when we run a prediction model, so now we're going to try and run a prediction model. So, prediction model, and all we do is we want to predict based on these things, if things are all significant. Now, do realize, if some of them were insignificant, and you wanted to rerun, you would be required to rerun the model again by removing the x's that weren't significant, only including the ones that are significant. And after that, you rerun it till all of them are significant. And when you take them off and you rerun it, you'll see the coefficients change. So make sure, in this case, everything is significant, so we're just going to work off the whole set. So let's assume that we want to look at, suppose the studio is looking at a movie with a 100-minute long duration with 400 Facebook likes, 1,000 voted users, I don't know, 1,500 for the total cost, budget of maybe 7 million, and IMDb score of 7, and then you could start saying, hey, this just came out at a premiere, and this is what can we predict what the movie is likely to cross over time. And then movie Facebook likes seem to be possibly 500, and color or black and white, let's say it's color. And we want to see, can we predict what the movie is going to make or gross based on these numbers? All we do then is say equal to, and what we'll do is we will say this is a constant, the intercept, right? That's where it begins. So if we were to remember it, that's the intercept, that's the constant. This is where the slope begins. So we need to provide the constant first, plus. So instead of doing 100 times 198,227 plus 400 times negative 1255.97, all we do is we use a function called sum product, which will do all that calculation for us. So we want to just provide them one array over the other. So we're saying this array times this array. Fair? I'm going to do it once again just to make sure that makes sense. So, and then we click enter, and guess what? We find this number. Now let's convert that into dollars so that it starts making a bit more sense. So we'll have 2 decimal points and into currency, and now it's saying that you're likely to make $11 million, $324,167.36. And then, of course, you know your budget, so you can now say, what's going to be our profit prediction? And we'll say that, oh, it's nothing but what we estimate is going to be, or what we predict is going to be on gross minus your what's it called, a budget. So, and you click on it, and it tells you that, hey, you're likely to make a $324,167.36 in profits. So same thing, if you were to simply change this set and say, all right, let's try it with 120 minutes of movie, but possibly, let's say 700 users or 700 voted users, then suddenly your prediction is 15,200,000 and your profit prediction is different. So you can play around with these numbers, and that's how we start doing a prediction. That's a very basic structure, but mainly understand that each of these things actually mean things, which means if you were to now prioritize and say, where should we put our money in? The answer seems to be the most impact seems to come from the duration. So if you can budget the cost of shooting a movie where you don't have to do hundreds and thousands of hundreds of takes, and therefore you don't have to spend too much time costing it out, then possibly duration gives you the best return on investment, followed by making the movie in color. followed by the number of voted users, followed by the number of Facebook likes. So if you try and increase the number of users who are voting, it's going to impact the movie. Number of Facebook likes for the total cost is going to impact the movie. The budget is not a good idea because it basically has a diminishing return to scale. Same thing, you're also saying that good movies are good movies, but you also don't want the movie to be so good, and it might be a fantastic bit in terms of technical direction that has a very high IMDb score, but it might not actually, might end up diminishing your ROI. So this gives you a good sense. I hope that made a little bit of sense, and thank you very much. I'll see you next time when we talk about something else.